All right, so 4.2 is on odds. Odds is a topic that relates to probability, but it's a little bit different than probability. But because it relates to probability, it kind of makes sense to talk about odds in this chapter. I wrote a definition down for odds, and that definition, if you knew what odds were, would maybe make a lot of sense as you read through it. But having not been exposed to odds, maybe the definition wouldn't make so much sense. So let me walk through the definition and then write an example to help you understand the definition. So odds is a ratio, and a ratio could mean a fraction or a comparison of numbers. And in this section, when we do odds, instead of creating fractions, we're going to form a ratio with colons. It's a ratio or comparison between the number of favorable outcomes of an event to the number of unfavorable outcomes of an event. So it's a comparison between two numbers, and the two numbers that it's comparing is the number of favorable outcomes for an event to the number of unfavorable outcomes. And in this section, we're going to study two kinds of odds: the odds against an event happening and the odds in favor of an event happening. And the nice thing about these is they're essentially the same. They're just kind of reciprocals or reverses of each other. Let me do an odds against first, because that's the more common kind of odds, and try to tie in an example to this definition. So I could say the odds against selecting the Queen of Hearts from a standard deck of cards is, and it's going to be 51 to 1. This is the ratio, or the comparison between two numbers, and the two numbers I'm comparing are 51 and 1. And those numbers I didn't just make up. I got those numbers in a very specific fashion. I looked at a deck of cards, and a standard deck of cards that we use in this class has 52 cards. And in this deck of 52 cards, there's one card in that deck that satisfies that it's the Queen of Hearts. So this deck has one Queen of Hearts, and of the other cards, the other 51 cards that aren't the Queen of Hearts, I lump them together as 51 cards that are not the Queen of Hearts. So when I found the odds of selecting the Queen of Hearts, I needed to compare the event of picking a card that's not the Queen of Hearts. This is selecting, so the first 51 is selecting a card that is not the Queen of Hearts. And the 1 is the number of Queen of Hearts. So I'm comparing two numbers. And in this case, if I'm trying to find the odds against selecting a Queen of Hearts, I need to break the deck of cards into two piles. One pile are all the cards that are not the Queen of Hearts, and the second pile would be the cards that are the Queen of Hearts. And in this particular problem, the odds against selecting the Queen of Hearts can be found by just taking and forming a ratio that compares the number of cards that are not, that means that's the against part of this, the Queen of Hearts, compared to the number of cards that are the Queen of Hearts. Let me talk about how these odds relate to probability, because you can actually compute odds from probabilities, although I'd like to avoid computing odds from probabilities. But on the next page, I give a formula. I say the odds against an event is the probability that an event fails to occur divided by the probability that the event does occur. That's a mess. Well, let me go through this a little bit. So the easiest way to compute the odds for any event is to just visualize the sample space and separate the sample space into sets or piles and use those numbers to compute the odds. You could, however, compute the odds for this particular problem using this formula. And let me doctor up this formula to make it more applicable. So the odds against selecting the Queen of Hearts can be found by doing two probabilities and forming a fraction. So the numerator needs to be the event that the event fails to occur. That means that I don't get a Queen of Hearts. So the probability of not drawing a Queen of Hearts or selecting a Queen of Hearts is the event failing to occur, and then the probability of the event occurring is the probability of drawing the Queen of Hearts or selecting the Queen of Hearts. So I can use probabilities to compute odds, and if you're using probabilities, then that 52 is going to come up. So I need to form two probabilities. One's going to be in the numerator of a fraction. The second probability is going to be in the denominator. The probability of not selecting a Queen of Hearts, because if you pick one card from a deck of cards, there's 51 cards that aren't the Queen of Hearts out of the 52 cards. The probability of not selecting the Queen of Hearts is 51 in 52. The probability of drawing or selecting the Queen of Hearts, because there's one Queen of Hearts in a deck of cards, that probability of selecting a Queen of Hearts is going to be 1 in 52. So this is an unsimplified version of the odds against selecting a Queen of Hearts. Of course, this is a mess because I've got a fraction over a fraction. Let me rewrite that to simplify this. And I can rewrite this as 51 over 52 divided by 1 in 52 by taking this fraction here and making it into a division. And then, of course, anytime you have a fraction and you're dividing, you can change it into a multiplication if you multiply by the reciprocal. So 51 over 52 divided by 1 in 52 is the same as 51 over 52 divided times 52 over 1. I'm going to cancel the 52s, and I'm going to be left with 51 over 1 times 1 over 1. And this, if I multiply across, 51 times 1 is 51. And if I multiply across the denominator, 1 times 1 is 1. This is the odds against selecting the Queen of Hearts written as a fraction. And when we do odds, usually we take fractions and write them as with a colon as a ratio like that. So this would be a way to use probabilities to compute odds. All odds can be computed from probabilities, but we don't have to use probabilities to compute odds if we can find the number of favorable and the number of unfavorable outcomes for an event. We can do the odds by just taking numbers and writing them down. Let me try to do another example for you. And maybe let's stay in the world of cards. Find the odds, or compute, in favor of selecting a spade from a deck of cards. So in order to find odds, the best thing I can do is look at the sample space, in this case the deck of cards I'm drawing one card from, and separate it into two groups, spades and not spades. And if I look at a deck of cards, every deck of cards has 52 cards, and in my deck of cards, if I counted up the spades, there's going to be, in my deck of cards, there's going to be 13 cards that are spades, and then the rest of the cards are going to be not spades. There's 13 clubs, 13 diamonds, and 13 hearts. If I add those up, I get 39 not spades. So those two numbers are going to be the numbers that I use to compute my odds. Just like the 51 and the 1 were the numbers I used to compute my odds against selecting a queen of hearts. The big deal here is when you do the odds against selecting something, the not number goes first and the R number went second. When I found the odds against selecting a queen of hearts, I did a 51:1 because I want to do the not having the quality and R having the quality second. If I want to do the odds in favor of selecting a spade, I want to flip the numbers and do the number that are spades first and then the numbers that are not spades second. So the only difference between odds against and odds in favor, after you separate the sample space into two groups, the group that has the desired characteristic and the group that doesn't have the desired characteristic, odds against has first the group that doesn't have the desired characteristic. Odds in favor has the group that has the desired characteristic first. So the odds in favor of picking a spade from a deck of cards is going to be 13 to 39. This will separate the deck into the cards that are spades and then are not spades. If I did this using the definition that I showed on the other page, let me see if I actually have that. Oh, no, yes I do. So I could compute this probability or this odds using probability, and the odds in favor of an event are gotten by forming a fraction that has the probability that the event occurs in the numerator and the probability the event doesn't occur in the denominator. If I did it this way, my work would lead to a fraction that I might want to reduce. And let me show you what I mean here. So let me get this. I'm going to compute the odds in favor of selecting a spade using a probability formula. So there's two ways to compute odds against, and there's two ways to compute odds in favor. The easy way to do it is just to count up the number of, to segregate the sample space into two piles, the pile that has the desired characteristic and the pile that doesn't have the characteristic, and then take those numbers and put them in the right spot. If you're doing the odds in favor, you want to take the number of items in the sample space that have the characteristic and write them first. If you're doing odds against, and you want to take the number of items in the sample space that don't have the characteristic and write them first. We could do any odds with probabilities, and to find the odds in favor of selecting a spade, we'd have to form a fraction that has probabilities in the numerator and probabilities in the denominator. The odds in favor of selecting a spade would be computed, or can be computed, by forming a fraction that has the probabilities of selecting a spade in the numerator and the probabilities of selecting a not a spade in the denominator. And I'm shortening this up a little bit just because maybe it makes it easier to follow. I'm going to do this with fractions now. The probability that I select a spade, if I pick one card from a deck of cards, because there's 13 spades of the 52 cards, is going to be 13 and 52. And the probability of selecting not a spade, because there's 39 cards of the 52 that aren't spade, would be 39 and 52. I'm going to do the same thing that I did to the last example. I'm going to rewrite this as 13 and 52 divided by 39 and 52. If it bugs you that I didn't reduce, that's good, because I really would want to reduce, but I'm going to hold off on my reducing for a second here. I'm going to invert my fraction, make this a multiply, make this 13 and 52 times 52 and 39. I'm going to cancel just the 52s to make my numbers look the same temporarily here. This is going to give me 13 over 1 times 1 over 39. And I'm going to multiply 13 times 1 and get 13, and 1 times 39 and get 39. This is a fraction, and it feels real comfortable for me to reduce this fraction. I'm going to go reduce this by 13. I'm going to go 13 divided by 13 is 1. 39 divided by 13 is 3. When I use the formula to compute the odds in favor of selecting a spade, it feels real comfortable to reduce the fractions. And this 13 and 39 reduces to 1 and 3. And if I was answering the question, find the odds in favor of selecting a spade from a deck of cards, although this is correct because it actually compares the number of spades to number of not spades, it's not reduced. And when you have ratios like this, you have to think of these ratios as a fraction. So when I reduce the fraction 13 over 39 by dividing by 3, I can reduce this ratio by dividing by 3. And probably a better answer to answering the question, find the odds in favor of selecting a spade from a deck of cards, probably would be 1 to 3. By dividing each of the 13 and the 39 by 3, we'd get 1 to 3. Generally, when we have fractions we reduce, and also if we have odds we reduce, and we reduce the odds just like it's a fraction. That's a pretty quick example, and I don't know that I've done enough or not enough to do some homework, but I'm going to try to do some homework with you right now. So let's just jump right into the homework and see where it goes. So in her wallet, Ann Kelly has 14 bills. So let me look at her wallet. She has 7 $1 bills. So in Ann's wallet, she has 7 $1 bills. She has 2 $5 bills. She has 4 $10 bills. That's backwards. She has 4 $10 bills. That's 7. Whoa. Let me recalibrate. I'm going to cut this out and put this in. So it could be a bit of a hiccup because I started doing this problem. I didn't like what I did. So I didn't want to lecture too much on theory in this section. I just kind of want to jump into problems. And it might be a little early, but if I walk through problem 1 with you, I hope it isn't too early. So as I read through problem 1, Ann Kelly has 14 bills in her wallet. She has $1 bills, $5 bills, $10 bills, and $20 bills. Let me just look at Ann's wallet real quickly and write down what she has in her wallet. So she has $1 bills, she has $5 bills, she has $10 bills, and she has $20 bills. She has 7 $1 bills, she has 2 $5 bills, she has 4 $10 bills, and 1 $20 bill. If I add these up, 7 plus 2 is 9, plus 4 is 13, plus 1 is 14. That makes the 14 bills Anne has in her wallet. So she passes a volunteer seeking donations for the Salvation Army and decides to select one bill at random from her wallet to give to the Salvation Army. Determine, and I ask a couple of probability questions and a couple of odds questions. Odds and probabilities are similar, but we're going to compute them differently. So let me just jump into these. What's the probability that she selects a $5 bill? So I'm asking the probability that she selects a 5. And to do probabilities, we're going to form fractions. In the numerator of the fractions, it's going to be the number of the bills that have the desired characteristic. In this case, it's a $5 bill. There's 2 bills in her wallet that have the desired characteristic. It's a $5 bill. And when I'm forming probabilities, the total number of bills in her wallet is going to go in the denominator. The probability that she selects a $5 bill reduced is 1 in 7. Part B says, what's the probability she does not select a $5 bill? And I'm going to form a fraction. For probabilities, the denominator is going to be the number of bills that she has in her wallet. In this case, it's going to be 14. And the numerator is going to be the number of bills that aren't $5 bills. And that's going to be 12, because in her wallet, she has 7 ones, 4 tens, and 1 20. That's 12 of her 14 bills that aren't $5 bills. And if I reduce this fraction by 2, I get 6 and 7. So the answer to part B is going to be 6 and 7. For part C, what are the odds in favor of her selecting a $5 bill? The easiest way to compute odds in favor is to break the bills in her wallets up into 2 categories. The categories are going to be, in this case, are $5 bills and are not $5 bills. Because when I'm asked to compute the odds in favor of an event, I'm going to go through and I'm going to count up all the elements in the sample space that have the desired characteristic and write the R first, and write the elements that don't have the desired characteristic second. So now I need to look at her bills in her wallet and figure out how many R5s, and that's easy. The number that R5s are going to be 2. So the first number I'm going to write is going to be a 2, and then I'm going to write a colon, and then I need to write the number of bills that aren't 5s. And the number of bills that aren't 5s would be those 7 ones, those 4 tens, and that 120. If I add those up, that's going to be 12. So the odds in favor of her selecting a $5 bill would be 2 and 12. I'm going to treat this as the fraction 2/12 and divide each of these by 2. And when I do that, I'm going to get an answer that's suitable for a test. So I'm going to divide 2 divided by 2 and get a 1, and 12 divided by 2 and get a 6. When I go to do part B, I'm doing the odds against selecting a $5 bill. When I go to do the odds of selecting against something, I need to break the sample space up into the ones that don't have that characteristic and the ones that do have the characteristic. I just need to flip this over. So to do the odds against, selecting a $5 bill, I need to break up her wallet into bills that are not $5 bills, followed by bills that are $5 bills. So the only difference between the odds in favor and the odds against are these numbers are switched, because in Anne's wallet there's the 7, 4, and 1 are 12 bills that are not $5 bills, and there's the 2 bills that are $5 bills. I'm going to reduce this as a fraction, but I'm going to leave both numbers. So when a number reduces to 1, I'm going to leave it, even if it would kind of be in the denominator of a fraction. So to reduce this, I'm just going to divide by 2. 12 divided by 2 is 6, and 2 divided by 2 is 1. So I wanted to do odds and probabilities together just because it felt like we should not forget probabilities as we do odds. So let's move on to 3 and 4. And for problems 3 and 4, we're assuming one card is being picked from a deck of 52 cards. We need to find the odds against and the odds in favor of selecting and then whatever we're selecting. I'm going to do number 4. And first thing I'm going to find is the odds against selecting a red card. And to do the odds against selecting a red card, I need to separate the deck into the number of cards, the number that are not red first, and then followed by a colon, and then the number that are red. When you go to do your odds against selecting a heart, because it's against, you want the not first. You want to find the numbers that are not hearts, followed by the numbers that are hearts. So for my deck of cards, or for any deck of cards, the red cards are the hearts and the diamonds. And so for the number of cards that are red, there's 13 hearts and 13 diamonds. There's going to be 26 red cards. The clubs and the spades are the not reds. There's 13 clubs and 13 spades. There's going to be 26 cards that are not red. When I go to do my probability or my odds, I'm going to write the 26 that are not red first, followed by the 26 that are red second. I'm going to treat this as a fraction and reduce it by 26. I'm going to go 26 divided by 26 is 1 for both of the 26. So this is going to be the odds against selecting a red card. And now I'm going to do the odds in favor of selecting a red card. And I have all the numbers that I need. I just need to reverse them. To do odds in favor, you want the are first and the not second. So I'm going to do the number that are red first and the number that are not red second. There are 26 red cards in my deck, so I'm going to write 26 first, then my colon, and there's 26 cards that are not red. I'm going to write those second, and then I'm going to divide each of those 26s by 26 and get 1 to 1. When you go to do your problem 3, for the odds against selecting a heart, you're going to have 39 to 13, which is going to reduce to 3 to 1. And when you go to do your odds in favor of selecting a heart, always odds against and odds in favor are just the flips of each other, so you're going to get 1 to 3. Let me walk through 5 with you because it's basically the same problem. So for number 5, I want to do the odds against selecting a 7 first. Odds against selecting a 7. So I need to separate the deck into not 7s and are 7s. So as I look at a deck of cards, in my deck of cards, there's 52 cards. There's 4 that are 7, and the rest of the cards, anything that's not a 7, can be found by taking the 52 cards, minusing the 4 7s, and you get 48 that are not 7s. So if I want to do the odds against selecting a 7, I'm going to do first the 48 cards that are not a 7, followed by the 4 cards that are a 7, And then I'm going to divide these by, I'm going to divide by 12, I'm going to divide by 4 and divide by 4. And for my odds against selecting a 7, 48 divided by 4 is 12, 4 divided by 4 is 1. Next thing I'll do for number 5 is find the odds in favor of selecting a 7. And then for this, I want to do the R7s first and the not 7s second. There's 4 cards in my deck that are 7s. There's 48 cards in my deck that are not 7s. And I'm going to reduce these by dividing by 4. 4 divided by 4 is 1. I'm going to leave my colon, and 48 divided by 4 is 12. So the odds against selecting a 7 is 12 to 1. The odds in favor of selecting the 7 is 1 to 12. 7 and 8 are a little bit trickier. I'm going to do 8. So for number 8, the odds against selecting how about this? A diamond or I can't do spades, can I? Or a spade equals to the number that are not diamonds or spades, colon, the numbers that are diamonds or spades. And now I need to go through my deck of cards and figure out how many cards are diamonds and spades and then how many are not. It's easier for me to do the R. So for the R diamonds or spades, there's 13 diamonds and 13 spades. So there's going to be 26 that are diamonds or spades. And then the clubs and the hearts are not diamonds and spades. And for the not diamonds or spades, there's the 13 clubs and the 13 hearts, and there's 26. So for each of my numbers, they're going to be 26. The first number, I want the number that are not diamonds or spades, and that's going to be 26. And then my colon, and then the second is going to be my numbers of diamonds and spades, which are going to be 26 again. I'm going to reduce these like they're a fraction and divide them by 26. And each of the 26s, when you divide it by 26, you get 1. So the odds against selecting a diamond or a spade are 1 to 1. The odds in favor of selecting a diamond or a spade are going to be the numbers that are diamonds, or I don't know why I try to make these symbols that I can't, compared to the numbers that are not. And the number that are going to be 26. The numbers that are not is going to be 26. And this is just going to be 1 colon 1, or 1 to 1. I probably should be lazy. If I know the odds against an event, I just flip the numbers to get the odds in favor. That will work every time. So when you go to do your problem 7, to do the odds against for number 7, for the odds against, I get 11 colon 2, which automatically means the odds in favor are going to be 2 to 11. To get this number before you reduce, in my deck of cards, there's 44 cards that are not 7s or queens, and there's 8 cards that are 7s and queens. So 44 and 8 are going to be the numbers that you're going to need to use as you go to do the odds. 9 and 10 are a little bit trickier. Let me do number 9 with you. So I'm going to do the odds against selecting one card that's a 7 and a heart. And in order to do this, I need to first put the number of cards that are not both 7s and a heart, and then the number of cards that are a 7 and a heart. And is a lot different than or. So I'm going to go through my deck of cards, and I'm going to separate them into the cards that are 7 and hearts and then are not 7 and hearts. And for the 7 and heart, there's only one card in my deck that qualifies as being a 7 and a heart. So for the side that says I want something to be a 7 and a heart, you only get one card that fits that category. So for the R, 7 and hearts, it's just the 7 of hearts. And for the not 7 and a heart, it's everything else. So that every card that I haven't circled is not both a 7 and a heart at the same time. And there's 51 other cards that I haven't boxed. So there's only one card that fits the R. It's both a 7 and a heart. That's different than or, because if this was 7 or a heart, I'd count up all the hearts and the 7s, but I need one card that's both a 7 and a heart. I'm only counting the 7 of hearts here. So for the R part of this, it's going to be a 1, and for the not part, it's going to be a 51. So the odds against selecting a 7 and a heart is going to be 51 to 1. And then, super simple to do the odds in favor. The odds in favor of selecting a 7 and a heart is just going to be 1:51, because they're always the reverse of each other. If you know one, you can flip it to get the other. So let me do 12, and you can do 11. So for 12, I'm going to do the odds against selecting the 4 of diamonds. And that means I need to form two numbers. I need the number of cards that are not the 4 of diamonds, and then the number of cards that are the 4 of diamonds. And that's easy for me. I don't even need to look at my sample space. I know there's one card that's a 4 of diamonds. There's one 4 of diamonds in the deck. The other cards that aren't the 4 of diamonds will go over here. There's 52 cards in the deck. One of them's a 4 of diamonds, so the other 51 are not 4 of diamonds. And of course, if I know the odds against, I can tell you the odds in favor without doing any extra work. The odds are in favor of selecting the 4 of diamonds is going to be 1:51. For your number 11, your answers are going to be the same. Your odds against are going to be 51 to 1. Your odds in favor are going to be 1:51. All right, 14 and 13. Let's do 13 together. So for 13, first I want to do the odds against. I don't know why I want to put those letters together. The odds against selecting a red king first, and then I'll do the odds in favor. So for the odds against selecting a red king, I need the number of cards that are not red kings, followed by the number of cards that are red kings. So let me look at my deck of cards. It's easier to do the R red kings first. Diamonds and hearts are the red cards. And in my deck of cards, there's 2 cards that are red kings. That would be the King of Diamonds and the King of Hearts. The rest of the cards that I haven't circled are not red kings, and there's going to be 50 of those that are not red kings, because these numbers have to add up to the 52 cards. So the numbers that I need for my odds are the 50 that are not red kings, followed by the 2 that are red kings, I'm going to treat that as a fraction and reduce by 2. My answer to 13 for the not is going to be 25 to 1 just by dividing those by 2. And then, of course, if I want to do the odds in favor of selecting a red king, I'm just going to reverse this and say it's 1 to 25. I could do this. I could say that it's the number that are red king, colon, and then the number that are not red king. By reversing these, you'd get 2 colon 50, and then you can reduce. All right, so done with the cards. Moving on to dice. So this might be a new sample space for us, but it's one that we're going to use a decent amount. So a pair of dice is rolled and the sum of the dice is recorded. Here's the sample space. So we have a first dice and a second dice. It could happen that the first dice is a 1 and the second dice is a 1. If you added up the 1 and the 1, you'd get a sum of a 2. It could happen that the first dice is a 1 and the second dice is a 2. So this is first, these are the first dice here. And these are the second. And each one of these elements in the table is part of the sample space. The numbers in the left-hand column are the numbers on the dice. The numbers in this table are the sample space. And the sample space for rolling 2 six-sided dice has 36 elements. If you counted up these numbers right here, there's going to be 36 items or elements in the sample space. And each element has 2 things. It has the numbers on the first dice, the number on the second dice, and then I add up the 2 dice. So here, one of the 36 elements is the first dice came up a 3, the second dice came up a 4. When you add the 3 and the 4, you get a 7. So let's do some probability and odds questions with the sample space. And this is your number 15. So I'll walk through 15 with you, and we'll do them one at a time. 15, what's the probability? So let me just do 15A like this. The probability that the sum of the 2 dice is a 7. When I'm asked to do a probability question, I'm going to form a fraction. The numerator of the fraction is going to be the number that have the desired characteristic. The desired characteristic here is the sum is a 7. If I look through, each row has a 7. There's 1, 2, 3, 4, 5, 6 7s of the 36 elements in the sample space. The numerator of the fraction for the probability of the sum of the dice being a 7 is going to be a 6. That's from the 6 items in the sample space, 1, 2, 3, 4, 5, 6, that are 7s. The denominator is the 36 different elements in the sample space. And I'm going to reduce that fraction, and I'm going to say the probability that the sum of my dice is a 7 is 1 in 6. For part B, the probability that the sum is not 7 is going to be found by making a fraction. The denominator of my fraction is going to be 36 because there's 36 items in my sample space. The numerator of my fraction is going to be all of the numbers in my sample space that aren't 7s, and that's a little bit tricky. So there's 36 items in my sample space. What I could do is just go and count every single one that's not a 7, and that's what the numerator is going to be. And I'm putting little marks through these with the idea I might have to use the sample space again. If I count up everything that I put a slash through, I put a slash through every single number that in the sample space that the sum wasn't a 7. There are 6 that are 7s. 36 minus 6 is going to give me 30. If I counted up all my green little slashes, there's going to be 30. So the numerator for my fraction is going to be 30 because there's 30 of the 36 numbers in the sums that aren't 7s. I'm going to reduce these by 6. 30 divided by 6 is 5. 36 divided by 6 is 6. Now on to some odds. 15C, I want the odds in favor of the sum being a 7. So that means I need to separate the number in the sample space that are a sum of 7 to the number that are not a sum of 7. And I have those numbers so nicely here because right here there are 1, 2, 3, 4, 5, 6 items in my sample space that are a sum of 7. So the first number I'm going to write is a 6 for the 6 elements in my sample space that are a sum of 7. And then I want the number that aren't the sum of 7. That's all these green ones. There's 30 that aren't a sum of 7s. I've computed these numbers when I computed the numerators of each of the probabilities, because the number that went in the numerator of the first probability was the 6 that were a sum of 7. The numerator that went in the fraction of the second probability was the 30 that aren't the sum of 7. So odds are similar to probabilities. They have some of the same numbers, but they reduce and they look different. Now I'm going to reduce these by 6. 6 divided by 6 is 1. 30 divided by 6 is 5. Now move on to part D. That's completely different. Find the odds against the first dice showing a 5. I better pull out a new sheet of paper to do that. So part D for 15. I want the odds against the first dice showing a 5. So that means I need to separate the sample space into the number where the first dice is not a 5, followed by the number where the first dice is a 5. That's a little bit harder. So let me try to look through my sample space. Here's my first dice, here's my second dice, and for the number where the first dice is a 5, this is what I'm going to be counting. These right here are the elements in the sample space where the first dice is a 5. So there's going to be 6 where the first dice is a 5. And that's the second number that I need in my odds against. The first number I need is the number where the first dice isn't a 5. That's everything that I haven't blocked highlighted. So 6, 12, 18, 24, 30. Those 30 that I just walked my hands through, there's 30 where the first dice or the first number is not a 5. So the next number I'm going to put in my work is a 30 for the 30 where the first dice isn't a 5. And now I'm going to reduce these. And when I reduce these by 5, I'm going to go 30 divided by 5 and 5 divided by 5. 30 divided by 5 is 6. 5 divided by 5 is 1. I'm going to say, oops, I should divide by 6, shouldn't I? No, 30 divided by, I made a mistake here. For the number where the first dice is a 5, I had these two numbers here. This should be a 6. There's 6. 1, 2, 3, 4, 5, 6 where the first dice isn't a 5. This should be 30 to 6. And then when I divide by 6, 30 divided by 6 is 5. 6 divided by 6 is 1. Let me slow down and say that again. So I needed to separate the sample space into the groups where the first dice was and wasn't a 5. There are 6 where the first dice is a 5. If I do 36 minus 6, I get the 30 where the first dice is not a 5. So the numbers I need in my work are a 30 and a 6. The 30 that goes first because I want the not first, and then the 6 goes second, and then I reduce that. part E wants a probability, which is a little bit different than a odds. So let me do part E for 15. For 15, I want the probability that the sum is less than 7. For these probabilities, I'm going to put 36 in the denominator because there's 36 different items in my sample space. The numerator needs to be any pair here that has the desired characteristic that the sum is less than 7. And for this one, I'm going to count this. I'm going to circle in red anything I'm counting where the sum is less than but not equal to 7. So if the sum is 7 or greater, I'm not going to count it. So I'm only counting sums that are less than 7. I'm boxing those in red, and then I'm going to count them up real quickly here. So those things that I just boxed out in red are the only sums that are less than 7. Everything that I haven't boxed in red is 7 or bigger. If I'm trying to find the probability that the sum of the dice is less than 7, I need to go through the sample space and count up all the sums that are less than 7. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 sums that are less than 7 of the 36. And that reduces by 3. 15 divided by 3 is 5. 36 divided by 3 is 12. My answer for 15E should probably be 5 and 12. Boy, this is a monster problem. For part F, find the odds against the sum being less than 7. To do 15F, to do the odds against the sum being less than 7, I need to find the number in the sample space where the sum is not less than 7, because it's odds against, and then the number in the sample space where the sum is less than 7. And this is going to be kind of easy because I know the second number that I need. The number that goes in the second number is the 15 where the sum is less than 7. So the second number in my odds is going to be the 15 that I have boxed out there where the sum is less than 7. And then the first number is going to be the ones that aren't boxed. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. There's 21 in my sample spaces where the sum is not less than 7. So these two numbers have to add up to the 36 elements in the sample space. I found out that there were 15 that had the sum less than 7 when I did part E. The difference between 36 and 15, or 36 minus 15 is 21. That would be another way to get that number. Now I'm going to divide these by 3. 21 divided by 3 is 7. 15 divided by 3 is 5. The odds against the sum being less than 7 is 7 to 5. On to part G. Find the probability of rolling a double. So for 15G, the probability of a double. When I'm doing probabilities, I'm going to form a fraction, and in the denominator of the fraction, I'm going to put 36 for the 36 elements in the sample space. The numerator needs to be the number of doubles, and double means both dice having the same number. And the doubles are, here's a double, a 1, 1, a 2, 2 is a double, a 3, 3 is a double, a 4, 4, a 5, 5, and a 6, 6. There's 6 doubles that occur in the sample space. So the numerator of my fraction, when I'm trying to find the probability of rolling a double, is 6, because there's 6 doubles. The denominator is 36, because there's 36 elements in my sample space. And when I reduce that, I get 1 and 6. When I want to do part H, the odds against rolling a double, I want to separate the sample space into the part of the sample space that is not a double, followed by the part of the sample space that is a double. I already know the second number I need is 6 because there's 6 doubles in my sample space. The next number I need is to go through the sample space and count up the number that aren't doubles. That's a pain to do. If there's 36 elements in the sample space and there's 6 doubles, the difference between 36 and 6, the 36 in the sample space total, subtracting out the 6 doubles, that would give me 30 that aren't doubles. I could count up everything that's not circled in blue, and I'd get 30 that are not doubles. So for the not double side of this, I'm going to put 30. I'm going to reduce these by 6. 30 divided by 6 is 5. 6 divided by 6 is 1. And my answer to part H, the odds against rolling a double, is going to be 5 to 1. All right, so that was a monster problem. Let's work through 17 together, because I don't really have an even number problem like it. Maybe you can pause the video and give it a try. So, for 17A, one person is selected at random from a class of 16 men and 14 women. Find the odds against selecting a woman. So the odds against selecting a woman, I need to separate the group into the number that are not this characteristic, so the number that are not women, followed by the number that are women. Because to do odds against a certain characteristic, you need the not first and the are second. And in this group, there are 16 that are not women and 14 that are women. I'm going to divide these by 2. And for an answer to part A, I'm going to get 8 to 7 would be the odds against selecting a woman. For the odds against selecting a man, I'm going to do for part B, put number that are not men first, followed by the number that are men second, and the number that are not men are the 14 women. The number that are men are the 16 men. And then I'm going to reduce this by 2. 14 divided by 2 is 7. 16 divided by 2 is 8. And my answer for part B would be 7 to 8. Just a few more problems left to go with dartboards. So a dart is thrown at this target, and the color it lands on is noted. Find the requested odd. So my dartboard has 3 sections, a red one, a blue one, and a purple one. I'm going to need to make the sections equally sized. So I'm going to need to make this dartboard have 1 red section, 1 blue section, and 2 purple sections. That way, if I throw a dart at this dartboard, each one of the 4 sections is equally likely to be landed on. So if I want to find the odds in favor of landing on a purple region, I'm going to, now that I have 4 equal regions, the odds in favor are going to be the number of regions that are purple, followed by the number of regions that are not purple, because when I do an odds in favor, I do the are first and the not second. For this particular dartboard, when I make the regions equal, there are 2 that are purple, and the red and the blue, there's 2 that are not purple. I'm going to reduce those by 2, and each one of those 2's is going to reduce to 1. For your 19, the odds in favor of landing in the blue, you're going to do the number that are blue, followed by the number that are not blue. The number that are blue is going to be the 1, and the number of equally sized ones that aren't blue is going to be 3. That would be your 19. I'll show 21 up with the same dartboard. It'll be the last problem that we do. And then for your 21, the odds against the landing in the purple region, as a reduced fraction, it's 1 to 1. It would be 2 to 2 if you didn't reduce. All right, that felt a lot longer than I wanted it to feel. So hopefully you're feeling good about this. Hopefully I did well enough. But if not, always tell me. I could always redo any video that seems a bit confusing.